Hello everyone, welcome back to part 3 of our series on landslide susceptibility mapping. So far, we have explored the basic concepts of landslide, looked at key triggering factors, and worked hand-on with elevation and slope in our mapping process. Today, we are adding yet another essential piece of the puzzle, aspect. As you know, aspect or the direction of a slope faces plays a crucial role in landslide susceptibility mapping. It influences factors like sunlight exposure, moisture retention, and vegetation growth, all of which can impact the stability of slope in one or in another way. In this episode, we will dive into how to calculate and interpret aspects using ArcGIS Pro software and discuss its significance in assessing landslide risk. By the end of this session, you will have clearer understanding of how aspects integrate with other parameters to give a comprehensive view of landslide susceptibility. If you are finding this series helpful, make sure to like this video and subscribe to our channel for more insight. Also, feel free to share your thoughts or questions in the comment section below. So, let's get started. As you remembered in the previous video in part 2, we are working on how to compute slope. Today, we will give special emphasis for aspect. To compute both slope and aspect, we need to have a correct digital elevation model. So this is my study area, and the minimum elevation is 952 and the maximum elevation is 2897. This color indicates that the highest peak in this administrative unit, and the red and the yellow one indicates that the lower area with this area. So let's get started in computing aspect. First of all, we need to have a geoprocessing tool to access the geoprocessing wizard. You have different alternatives. The first one is go to analysis and click on tool, or the other alternative is you can go to view and there is geoprocessing wizard and you can click here. Then within the geoprocessing wizard, different toolsets are available for this practical exercise to compute aspect. We need to have a spatial analysis tool and drag, scroll down and expand here. For the available toolsets, aspect is found within a toolset called surface. Then double click on surface and the aspect is computed by using aspect tool. Double click and have access to the geoprocessing wizard of aspect, the input raster dataset that we use to compute our objective is the field digital elevation model. So select them. Then we, as usual, let's set our working directory and give a name for our output. Our output name is aspect. Then save it. The method is planner and hit run. Automatically, the digital elevation model is converted by using aspect tool to the aspect. As you know, the aspect is the direction of the slope faces towards a certain direction. And flat indicates -1. Within the attribute table or any pixel value which have less than 0 is flat, considered as flat. The northern direction, as it indicates, it is found between 0 to 22.5 degree that is 90 degree is east, and there is 45, between 45 and 0 there is 22.25. So the cardinal and subsidiary points are available here. The next step that we are going to do is we need to reclassify based on our threshold. Then to perform that, let's get back to geoprocessing wizard, and let's select reclassify by scroll up to reclass. From reclass we do have reclassify, and the input parameter to reclassify based on our threshold is the computed aspect. So the input parameter is aspect, and the reclassified field in the attribute table is the value. So go to classify, and let's get started to classify based on our threshold. So let's get back to our Excel data and let's have a look. This reference, this is north, northeast, east, southeast, south, southwest, west, northwest, and the flat or undefined value which have below 0 and negative values is very low, and the susceptibility rate is defined here. There is a range of degrees for each direction is listed here. Based on this, we would like to classify our data set. Then go to geoprocessing, and from geoprocessing, as usual, we need to have a reclassify tool. The input raster data is the aspect that we have generated from the digital elevation model. This is the negative value that indicates 1. 1 means very low, 2 is low, 3 is moderate or medium, 4 is high, and 5 is very high. And this will be, the sixth one will be 4. This is moderate. This range is lay within 3. Here is 2, and this is 1, and the final one, this is this will be 2. So let us save to the final working directory, aspect reclass, and save it and run. So now we have 5 classes. One indicates very low susceptible in terms of aspect, and 5 indicators that very high susceptible for landslide. Let's visualize in a better color ramp. To perform that, right click here and go to symbology. From symbology you can change your color ramp. So this is the aspect map of my area of interest. You can edit on the attribute table. To work with attribute table, right click here and open the attribute table. Okay, let's have a look at the attribute table. The attribute table indicates there is object ID. Here there is a value which is indicated the ranking level from very low to very high, and this is a pixel value which is found on my stereo area. So let's add the field which indicates that the class, add field, and the field name is class, and this class is textual value because I need to write from very low to very high susceptibility related to landslide. Then go to the upper part of the software, and here there is a save icon. Click here. Automatically it is saved, and the new field is created on the attribute table. Here there is a class name. Let's edit it. 1 indicates that very low susceptible. 2 is low. 3 is moderate or medium. Moderate, let me say moderate. Value 4 indicates high, and the final one is very high. Let me remove this and let's visualize again by using better color scheme. Right click and go to symbology. From symbology, I would like to take the field name as class because I have edited, and you can also select better color scheme. This is the aspect map of my study area. This red indicates high, the yellow one is low, this light green is moderate, then the deep green is very high, and this color is very low. So in such a fashion, we can easily compute aspect map of an area to make the integral part of landslide susceptibility map of our state area. This is all about aspect. In the upcoming video, we will continue with the rest parameters. Thank you.